So I had posted a link to the YouTube playlist in Google Classroom. So if you want to bookmark that, you can find the videos if you're ever absent in that location or if you want to study for a quiz or a test. I also posted the website for this class. There's a page on my website for Advanced Algebra 2 for all of my classes. And all you got to do is find that. And if you want to bookmark that, that's a good idea. So today we're doing 1-4. We're going to talk about evaluating expressions with absolute values in them. And we're going to talk about absolute value equations. Okay. So remember back in the day, let's talk about what absolute value means. Okay. An absolute value is really referring to a distance. A certain number of units away from 0. So sometimes it'll be classified as a distance from 0. Because it's a distance, let's think if we have the absolute value is 2. That is saying what things are 2 units from 0. So because we have 2 places at +2 and -2, where that's the case, we can think of an absolute value really encompassing 2 directions. So if you think about the fact that we could have the positive direction and the negative direction, that will help you to understand the fact that it is going to be a directional thing, so you can have 2 answers. So remember, the absolute value of 2 is 2. The absolute value of -2 is 2. So I always think of an absolute value does nothing to a positive, but for a negative, it will flip it to a positive, okay? Because distance should be a positive thing, okay? So if you look at our first example, it says to evaluate the expression. If you see those absolute value, those straight up and down bars, in most contexts, it means absolute value. So if we look at our first example, it is just a substitution, but you just have to be careful and be, I'm going to warn you about it. So we're going to take out the n we see here. We're going to replace it with -7.5. So all you've seen me done at this particular point is take out the n, replace it with -7.5. Now, the thing that you want to remember is you want to consider this like a grouping symbol in, please excuse my dear Aunt Sally. So we need to take the absolute value of the entire answer, not the pieces of it. Because what you can do is you can end up messing up your algebra if you try to make everything positive and then get an answer. No, it is the positive version of the entire thing. So that being said, let's do some math here. We would do the 2 times -7.5, and that's -15 plus 5, which is -10. Now, once we have an answer, it is the absolute value of our answer. The absolute value of our answer. So now our absolute value is done, what an absolute value does. So the absolute value of a negative is a positive. So this is going to become a +10. So just a plain old 10. But there was a negative already on the outside of it. That negative on the outside stays there because we're really saying we want the opposite of this positive thing, which is becoming a subtraction or a negative. So be very careful. Do the absolute value, then look what's on the outside of it, okay? And then 8.4 minus 10 gives me an answer of 1.6, okay? So just be mindful of that. Don't do weird things. It is the absolute value of the final answer on the inside, okay? So now let's look at where we have more of a context. Now, absolute value is used a lot for what's called error. So if you have this plus or minus error here, absolute value is used quite a bit, okay? So let's read the question and then we'll talk about what's what. It says a standard tennis racket has 100 square inches head and 20 square inches, or plus or minus 20 square inches. So that means that the top of the tennis racket should cover an area of 100 square inches, but it's a plus or minus 20, so it might be a little smaller, it might be a little bigger. And then it says write and solve an equation to determine the least and greatest sizes for a standard racket. So let me show you how this is going to work, okay? This should be what your ideal situation is. So in this case, the C is 100. Okay? And the R is your error. How much do you have wiggle room? And so just put 20, not plus or minus 20. We'll show you how that comes into play in a minute. Excuse me. So now let's take that and rewrite that absolute value equation. So we get the absolute value of x minus 100 equals 20. So what that means is if we were to measure the area of the racket, we should, if we compare it to 100, be only off by 20. Whether we're 20 above or 20 below, that's where the absolute value comes into play. Okay, so let me show you how we account for that plus or minus language. Okay, so there's two solutions. If the x minus 100 equals 20, or if the x minus 100 is the opposite of that. So maybe we're below by 20 instead of above by 20. So you should expect an absolute value equation will have two solutions. Absolute value inequalities, when we get to those, have kind of two little pieces and parts to it. And then you just solve each one independently. So here, the maximum value, if we add 100 to both sides, is 120. The minimum value, if we add 100 to both sides, is 80. So this is our greatest size to be a standard racket. This is our least, or smallest, to be considered a standard racket. So this is a good thing to think of. The C, again, is what we think the ideal perfect case is. The R is how much range we give. So if you think of R as kind of being our range, and that's where the 20 comes into play. Do we have any questions about solving that or how it was set up? I mean, if you think logically, if we're allowed to be 20 under and 20 over, it should make sense. 100 minus 20, 100 plus 20. And that's what your math should come out to be. So if you had these switched, you end up with some weird negatives happening. And so that's the way you can kind of tell which is which. So again, this is your ideal value. This is your range in above or below. Okay? Everybody okay with that one? Any questions there? Now, if we just apply that to an algebraic equation, like we see in example 2b, if those are just algebraic equations, somebody's already set it up for you, you need to recognize that absolute values have two cases. I think of it as the positive case, the over case, and the negative case, the under case. So we have to do both. So drop off the absolute values, just write exactly what's there, don't change a thing. That's your positive case. The other case, drop off the absolute values and multiply the right side by -1. That's your negative case. Okay? So let me say that again. Absolute value equations have two answers. The first answer, just drop off the absolute value and rewrite it. The second answer, drop off the absolute value and then change the sign of what you're equal to. So that's your positive direction and your negative direction. So two cases. Now, for the positive direction, the plus 12, we're going to subtract 12 from both sides. So x is -3. Here, when we subtract 12 from both sides, again, that's our lowest case scenario. negative 9, and negative 12 is negative 21. Now let's think about if we check it. If we check it back up in the original, let's plug in negative 3 into here. So if we have negative 3 right there, plus 12 gives us 9. The absolute value of that is 9. Let's think about if we plug in negative 21 right there. We would get negative 21 plus 12, which is negative 9. That answer's absolute value is 9. So you should be able to check it back in the original, and you shouldn't have a problem. 2 cases. Set it equal to the positive version, set it equal to the negative version, solve both. Okay? Let's do one more. So let me take a second. Try to set up the 2 cases for me, and then you can compare them to what I do. Try to set up the 2 cases for B, and then I'll show you when I'll do the same, okay? See what you can come up with. What are your 2 cases? Now, you don't have to solve them yet, but just set them up. Set up your 2 cases. You're going to pick on one of you to share with us. Cassidy, what did you get for your 2 cases?
X minus 5 equals 12, or y minus 5 equals 12, and y minus 5 equals 12.
Perfect. Okay. Do you see how she did that? She dropped off the absolute values, is equal to 12. Dropped off the absolute values equals the negative case, negative 12. Now, it's not always that easy. Sometimes you have variables on both sides, and you have to be a little more careful. But it's still kind of equal to the original, equal to the negative version. And now we're going to just solve them. So you'll notice both cases we add 5 to both sides. So here we get y equals 17. Here we get y equals negative 7. We can plug them back into the original. 17 minus 5 is indeed 12. Negative 7 minus 5 is negative 12, but when you take the absolute value, you indeed get 12. Okay. So that's 2 examples, kind of one of our, like a word problem, and then 2 examples of just a standard algebraic absolute value equation. Now here's where we have to be a little more mindful of the fact that it's an absolute value. Let's look at example 3. Let's look at example 3. Before you set up the 2 cases, you must isolate the absolute value. So the fact that we have that plus 8 there messes everything up. It has to say absolute value equals everything, or it's not going to work. So we're adding 8. Just do the opposite. Let's subtract 8 from both sides. When we do that, we get the absolute value of 3 minus x equals negative 7. Now, if you were to set up your 2 cases and then plug them back into the original, they don't work. Okay? Then absolute value is a distance. One of the first things I told you is that absolute value makes everything positive. So this is saying that the absolute value equals a negative. Does the absolute value equal a negative? No. So what's great about this case, one, you have to be aware of it and look for it. But if you get that the absolute value is equal to a negative, you can say no solution. There is no x we can plug in there to ever get us a negative number. So if you isolate the absolute value and you equal a negative, you can say, oh, nope, nope, that doesn't work. Okay? We can't add anything to 8 to bring us down to 1. It's impossible. We can't add a positive number to 8 to get 1. Everybody see why that was no solution. Isolate your absolute value. If you end up equal to a negative number, now you could be a negative x, that's different. But if you're a negative number just from the number line, you've got to throw it out. Okay? Okay. So now we have some with x's on both sides. So we have a little more work to do. Okay? So let's take a look at example 4. So let's focus in on A. Now your 2 cases are still going to be the positive case, so drop the absolute value away. Okay, so that's still our first case. Drop the absolute value, just rewrite everything. The second case, a little different. Okay, drop the absolute value off. Change the sign of the other side. Make it negative. Now, to make an algebraic expression negative, we have to multiply each piece by -1. So you can write a negative in front, in parentheses in front of the 4x minus 8. Or if you know that we just need to write the opposite, the 4 becomes negative and the 8 becomes positive. So if you want to see that with the parenthesis, I'm okay with it, great. If you don't and you just immediately switch the signs, I'm okay with that too. You decide how you like that. Sometimes I would suggest writing it like this for a little bit until you get the hang of it, but that doesn't matter to me, okay? Everybody see how we got the two cases? Okay, now once we've got the two cases, we just got to jump in and solve it. Okay, so let's do it. So, or let's move things around. So let's subtract x from both sides. And then I'm going to have my x's to the right. So that means probably add 8 to both sides. And when we do that, we get 18 equals 3x. And we just divide by 3. And so we get x is equal to 6. Okay? So 6 is our first answer. Now, same thing, but because now we have different signs, moving things around in different places might be a better option. Okay, so let's play around with this next one. I'm going to add 4x to both sides. Again, for moving around, as just the x's need to be on one side, numbers, plain numbers need to be on the other. It doesn't matter which way you go. I tend to go where it's going to be positive, but it doesn't matter. And then, so my x's now are on the left. So let's take off 10. Why not? And I get, let's see, 5x equals -2. Because our 10's canceled out, our -4's canceled out, so we were left with 5x and -2. Now here's where I don't want you to act like you were sitting in Algebra 1 class. I just want it over 5. If that -2 over 5 reduces, I want it reduced. If it doesn't, stop there. The decimal value is usually only helpful if we're going to graph it, if there's some kind of context of a real-life application. Otherwise, just leave it -2 over 5. So fractions are good. Don't waste your time putting 2 divided by 5 into a calculator. Just write it. Just leave it. Okay? Now, here's the problem with these type of problems. You have to check them. Now, we only have to check them if there are x's on both sides. There are x's on both sides. When I say check them, we have to check them up in the original version. Because the original version had an absolute value. It's going to make things positive where they weren't positive before. And so that's why we have to do that. Okay, so let's plug in 6 first. And you can do a little bit of math in your head, okay? On the left side, if we plug in 6, we get the absolute value of 16. The right side, if we plug in 6, we get 24 minus 8. The left side gives us 16. The right side gives us 16. Bam, it matches. Circle it. It works. So 6 is good, okay? That's okay. That's wonderful. Now we got to plug in -2/5. Feel free if you want to grab a calculator, but I'm going to show you how to do that in your head. Maybe. -2/5 plus 10. 10 is 50/5. So that's 48/5. 2 times 4 is -8/5. I'm going to write this down. -8/5 minus 40/5. Okay. The left side gave us 48/5. The right side didn't. It gave us -48/5. And you could use a calculator to verify, but that one doesn't work. Cross it out. Okay? So a lot of equations, a lot of stuff. I don't say, you must check this. But For an absolute value equation, when there's x's on the inside and x's on the outside, you can mess things up. Not that you did any math wrong. We didn't do any math wrong. But that change in sign messes things up. So here's my take on that. Anytime absolute value, x is here, check it. Because sometimes neither works. Sometimes both work. Sometimes one works. So you have to check them. There'll be square root equations you might recall from Algebra 1. You had to check them. So there are some things we have to check because mathematically you did nothing wrong, but it just doesn't work when you go to plug back in. Okay? Everybody good with A? Okay. Let's see about B. Now, yes, there are x's on both sides, but we have even more problems. We need the absolute value by itself, no matter what kind of problem it is. So we have to isolate this spot right here. Okay? The absolute value has to be isolated. When we get to square roots, they kind of act the same way. We got to isolate them. So I don't like this, especially. So let's immediately fix that by adding 2 x's to both sides. When we do that, it's almost isolated. And you kind of can get away with leaving it like this next step. But I am going to show you one more trick. If there is a numerical component on the outside, I do suggest dividing it off. Okay? So let's actually take and divide this side by 3. I have to divide this entire side by 3. Whether you show it both terms or you do like I did and just put the whole thing over 3, I don't care, whatever, okay? When we divide the left side by 3, the 3's cancel. We're just left with the absolute value of 2x plus 2. And then here, we have to divide both pieces by 3. 3x divided by 3 is 1x. If you put the 1, it doesn't hurt anything. I'm just going to write an x. 3 divided by 3 is 1. You have to have that 1 there, or it's not equivalent. So once we've actually isolated the absolute value, because that'll kind of check to see, did I get weird negatives on the other side or something like that? Once you've isolated, and only once you isolate it, do you set up the 2 cases. Okay, so remember your first case. Just write it down. Take off the absolute values. You don't change anything. Then write the word or. The second case. Take off the absolute values on the left. Change the sign or multiply by -1 on the right. Now you can put a negative in front of it, or you can just immediately change the sign of everything. I don't care how you do it. So if you like to see that parenthesis and that negative, go for it. But you can just go, bam, change the sign. So you notice this became a negative, and so did the 1. Okay, so however you want to write it, not a problem. Okay, does everyone see how we got the 2 cases? Do we have any questions about that step so far? Okay, so isolate the absolute value, 2 cases. Absolute value, the stuff inside equals the positive version, the stuff inside equals the negative version. And now we're going to solve each case. Here, I don't know, let's subtract x from both sides. So that means maybe move this 2 over here. So we get that x equals -1. Okay? So that is our first case. Okay. So our first possibility is -1. Now let's do the other side. So our second case. Let's move this x over here. Again, there's so many ways to solve an equation. I'm just showing you what occurs to my brain at this particular time. Doesn't mean it's anything fancy. Subtract 2 from both sides. We get 3x equals -3. Did I do that right? Did I mess up anything? Is that okay? Okay. And then I get x is -1 again. So there's only one version. So we only have to plug in one thing into the original topmost version. Okay? So let's go back to our original version. See it right here? That's where I'm plugging in -1, because if it doesn't work, I'm going to find what I did wrong. Okay? So we're going to plug in -1 for all of our x's. Okay, so let's do our little check. Did I do anything wrong? Is that okay? Does that look right? Okay. Okay, so sometimes when you guys look at me like that, I wonder. Okay, let's plug in -1. So we get 3 times the absolute value of 2 times -1. I'm just going to write -2 plus 2. Minus 2 times -1. I should have just made it 2. Equals -1 plus 3. Okay. So this is 3 times the absolute value of 0, which is 0, plus 2 equals 2. 2 equals 2. Yep, it works. It's okay. Okay. So our only answer for that one happens to be -1. So sometimes you get one answer, sometimes don't think because we only got one answer that you might not get 2. It happens. It just kind of, depends upon the situation. Okay. Do we have any questions about this one or any of the other ones we've seen? Okay. So you have a nice amount of time today to start the homework. Now, we have 2 assignments due at the end of class tomorrow. Section 1.3 and 1.4. So you don't really have enough that you have homework per se. You can use your time today. You can use your time tomorrow in class to work on these, okay? Now 1.4, I did not specify. There are only 13 problems here. Ignore the little circles. So your job is to complete those 13. So remember to include your notes tomorrow when you turn in your homework, and I'll remind you of that tomorrow. So you have the rest of class to work on this assignment or yesterday's assignment. And as you go through it, if you have any questions, all you got to do is ask, okay?